So my name is Mike Traverso again. What I do for my day job, and I'm an iOS developer, mostly doing Objective-C for the New York Yankees. So you're like, why is he here talking about this? I do some Android stuff on the side. I also help organize the Google developer group in the Tampa Bay area. So is there room for one more data persistence library? And I think yes, and I'm going to try to make that argument for you guys tonight. So when you have an Android app, you've got a few ways to kind of save some data, right? The easiest one is shared preferences. You've got SQLite. There's Realm or other object relational mapping. And now there's Room. So we'll go through a few of these. All right. So with SQLite, it's one option that a lot of developers tend to go to. It's pretty straightforward. There's a lot of documentation. There's a lot of sample projects. There's a lot of tutorials on how to use it. It's very well documented. And it allows you to create databases for your app. All right? But here's the problem with SQLite. You end up with a lot of boilerplate code. So here's an example where we're trying to create an entry in a table called events. So we dump all of our values into this content values, and we pass it along to our database insert here. And by the way, we're doing all of this on the main thread, right? We're not doing, so we're not forcing any of this here. We're kind of letting it up to the developer to kind of put this on the back, a background thread. So that's the other problem, right? Here we have like just getting data out of a table. So you've got to create a cursor. You've got to remember column names. You've got to do some really weird stuff where you've got to remember not only column names, but how to enter that. And sometimes when you have a database like SQLite, you tend to use these underscore column names. And so it gets really wacky really fast, and it's hard to read. And then one of the other problems with pulling data out is this, right? Anybody use SQLite in their apps or has? Try catch, right? Every time you have a date, it's obnoxious, and you have to do it for each one. So yeah, you can do that. You can use this, but what else is there? So recently Realm came out, and again, Realm is object relational mapping, stores objects and their relationships to each other. So with Realm, you still have some boilerplate code. You have these Realm versions of your POJOs, and that means your query results aren't your actual objects. They're kind of like these Realm objects. So you have to kind of be careful of how you use those. There are special versions of Realm lists, so you can't just have a regular list. You have to have a Realm list. So the other benefit is that with all of this ORM is you have this ability to kind of say, hey, I'd like to just use a query API and say, hey, go get me the customers that have this attribute equal to this value. So it's easier in that you don't have to avoid SQL. And if you don't like writing SQL, this is a huge benefit. There's also some optimizations that they do for speed. But you still need to make sure that if you have large queries or complex queries or large data sets getting returned, you have to make sure you deal with that, right? Realm is fast, but if you don't handle that properly, you could end up getting some jank in your app. And jank, I call jank like that stutter that you see, right, when you're trying to do something on the main UI thread for too long. Okay. So you can kind of do this in the back. You could do stuff with Realm, long stuff, have background tasks that'll run and get your data and move them onto the UI thread. So the problems with some of these with this is you've got some low-level APIs, there's a big effort for development. You've got raw SQL in some cases, with SQLite. You have to manually update your SQL statements, right? Versions. So if you have a customer who comes in and says, hey, I want to have this field added to this table, or I want to do this, you have to add that field to the table. Now you've got to manage the versions, right? And you've got people in the wild, so you can't just tell everybody, delete that old version, install this new one. It's just not going to work. So you've got to manage those versions. And it's just time consuming, it's error prone, there's a lot of boilerplate stuff, so you're going to screw up and there are going to be some problems. All right. So now there is Room Persistence Library. And so this was announced back at Google I/O this year. They announced this as part of their new architecture components for Android. And Among those new updates is Room. It's another way to persist your data in your Android apps. So it's object mapping library for SQLite. So it kind of combines these two things that we just saw, which is the realm and SQLite. And it uses annotations to help reduce some of the boilerplate code. So we'll take a look at what Room is. So Room, the Room persistence library guarantees SQL statements at compile time. So the neat thing is if you screw up a SQL statement, you select the column that doesn't exist. The IDE is going to tell you, hey, this doesn't compile anymore. You have to look at this. So it's a huge advantage right off the bat, just that feature alone. So, and it validates each of the queries against your schema so that any broken SQL queries give you those compile time errors and not runtime errors. Because a runtime error is something you're going to have to go through and have your testers hit or have maybe, unfortunately, your users hit and tell you, and that's not cool. It abstracts a lot of the underlying implementation details related to working with raw SQL, which is awesome if you don't like SQL. And you could use Room also with the new architecture components to observe the changes to your data and then update your UI as those changes come through. And we'll take a look at that and how we can use Room with live data and the view model, which are both architecture components. And it also defines thread constraints. So it helps you kind of figure out, like, well, one of the things Room does is it says, hey, you cannot do anything on the main UI thread. You have to force it to say, I want to do things on the main UI thread. So you can't, by default, you can't screw yourself up. You have to actually go and say, hey, I would like to be able to shoot myself in the foot. So please allow me to do that. All right, so Room is designed to abstract away the underlying database tables and queries and encourage best practice development patterns on Android, said someone at Google. I don't know who said that, but it was a cool quote I saw on their website. And this is one of the things I want folks to take away from this, is that it tries to abstract away a lot of the nonsense you've dealt with if you've done database stuff on Android. Okay. So here is a class, and awesome, or a little fuzzy, but you can kind of make out what this says. So we've got two imports here, our architecture library persistence room entity and persistence room primary key. So we have this class, so let's just assume this is a typical kind of user table, and we define the class with the entity annotation. We give it a primary key, which is just a string ID, and we have some fields. Now, I want to just point out the reason these are public is because I'm lazy and don't want to have to show another slide with getters and setters, so that's why they're public, okay? You could make them private. There's no limitation on that. So, excuse me. All right, so anybody remember data access objects? Anybody remember looking at something like this? All right, so data access objects are kind of how we're going to use to abstract the interface to some type of database. So this is what allows your code to pull that data into your application from the database. So here's how we're going to use this. We have this user. So how do we interact with that user entity here, right? So we create this user DAO interface. Again, you can call it whatever you want, doesn't matter. It's typically a good idea, though, to use the same name as your entity and then DAO so you can find it. The annotation up at the top, the @DAO, that defines this as a data access object. And then here we kind of have some queries, okay? So we have a query which says, we have an annotation @query, select star from user, and we define a method which says, give me a list of users, and the method for that is called load all users. We have another annotation here that says @query, select star from user where ID equals :ID. And here we ask for one user returned, load user by ID, and pass it in. So this is an example. Come on, just trying to find the cursor here. There we go. So here's an example up top of getting everything from that table. Here's an example of getting one user from that table by a parameter. And if you wanted to pass in multiple parameters here, so say find by name and last name, Here's another example where you can get a list of users back from that. So you're getting this idea, right? Like it's very, what's that? Yeah, so you could define like these simple.
Like hibernate and spring data.
Yes, it tries. Yeah, so I mean, like I said, we've got some loads, we've got some finds, inserts, and some deletes, and we'll get into those in detail. But I just want to point out, like, so this is your interface to access your data with your entity, your user entity. No SQL yet, except for some of these smaller bits, but we'll get past that for a second. All right, so your DAO annotations, you can query, insert, delete, and update, right? CRUD or CRUD, same thing. All right. I don't think there's a drop, so that's always good. All right. So here's a very simple query interface. So we're going to take apart what we looked at before. So we've got, again, we talked about our list of users from load all users, and our SQL was select star from user. Here we have our query select star from user where the ID, and we load that user by the ID. And then finally, we have another query where we ask for a list of users with that first and last name. So far, so good, right? All right. So here we have inserts. And we start with the @insert. And here we provide this parameter. So you don't have to use this onConflict. There is a default. I forget exactly which one it is. But here what we're saying is, look, with this first one, we're saying, hey, if there's a conflict, ignore it. Okay? Similar how you would deal with SQL issues. We insert the user, and we pass in a user object. And then here, we pass in a list of users to insert or replace users. The other options for this are rollback, replace, and abort. And fail, sorry. All right, here we have delete. Every once in a while, you need to delete something. So up top, we have our delete for deleting one particular user. So we say @delete to annotate this method delete user, passing in the user. Here we have a query. So we're going to delete users based on a query. So delete from user where the name like bad name or last name like bad name. So anytime we pass in this, any string that we pass into this delete users by name, it'll look for that and delete those users. So here we're deleting via query. Here we have another delete where we passed in a couple of users. We say delete users. And finally, delete from user. So it's kind of like our drop.
So in that case, that you have the same parameter of bad name for last name.
Yeah, you could pass in two parameters if you needed to. Like if you, this is just an example, right? Because what I'm trying to say is, hey, anything that has this name, get rid of it. If it's first name, if it's last name, I don't care. Get this person out of here. So like, for example, if it's, anybody named Jimmy in here? Perfect. So if it's Jimmy, okay, and we want to kick Jimmy out of the user table, that we would pass in Jimmy. And if he's got a last name of Jimmy or a first name of Jimmy, we want Jimmy out. Adios, Jimmy. Okay?
But it would have to be unique.
Yeah, I mean, it doesn't really matter. This is just an example, like whatever makes sense. You could do by ID, which would make a lot more sense probably, or by username and first name and pass in two parameters. Right? Because this is just a method, right? So you can add another parameter here. And so this could be bad first name, and then another one could be bad last name. Okay? Okay. So here we're going to talk about how we do that verification. And this is what I was talking about before at compile time. So here again, we have our user entity. So we have our primary key, string, first name, string of name, string for last name, and public int age, right? So if we were to go ahead and add a new method to our DAO interface, we'd want to pull out, and let's say we want to pull out all of the fields from user where the name column contains the name parameter, okay? So here we have this query, select ID, name, last name, and age, and then we have this DOB from user. This is our user table or our user entity, and we ask where name contains name, and we pass in name. But there's a problem with this, right? Anybody want to point out or think they know where the problem is with this?
The integer, you having an integer.
No, this is fine because this is, you're right. Java would be able to kind of understand what I was talking about by passing in the ID, a number in there and figure it out. So that's a good catch, but it's not what I was trying to look for.
But you're only getting part of the result back?
Well, no, I've added this extra column in there, DOB.
Okay.
So there's no DOB here.
Oh.
So
Okay.
what happened? So yeah, I kind of screwed that one up, but good catch. I'll make an update for that. So if we did this and we try to compile this, we would get this, right? Now it's not as clean as your error file from Codin, but you can kind of understand what's going on here. So it says, hey, in this user DAO Java file, you have a mismatched input that contains, and then all of this other stuff, right? So you're like, well, wait a second. It's expecting any of these other SQL keywords and not what we put in, right? Oh, sorry. My apologies. The issue here, what I want to point out here is this contains. So there's two errors here. I forgot about that one. So it contains. There's no contains. It's like. Okay. So the first it complains, hey, you're using a SQL keyword I don't know about. So let's change it. And we just swap out contains with like. All right. Now if we do it, if we try to compile this, now it complains that there's no date of birth. Okay. So it says right here, SQL error, missing database, no such column, DOB. So that's a lot easier to find than all that other mess. So one thing to note, if you screw up the SQL keywords, you're going to get this. It doesn't matter what it is. It's just going to spit out all of the possible SQL commands you could possibly throw at it. And you have to figure out where your SQL is bad. Yeah?
No question. So it's actually sort of parsing or checking the SQL against what database though? Because let's say Oracle and SQLite.
SQLite.
They might have different.
It's SQLite.
Right?
Yeah.
So it must be SQLite.
Yeah.
Okay.
Yeah, this is all built on top of that.
Yeah. Got it.
All right. So we say, hey, there's no DOB column. Okay. So finally, we drop that DOB column, and this will compile, right? Because everything else looks correct. We're selecting exact properties as they exist. We're not adding any others. We're not inventing new SQL keywords in our query, so everything should be fine. We won't have any build errors here. Okay. So I want to talk about how this all kind of comes together, right? So there's one more annotation here, and it's the database annotation. So here we create an abstract class that extends from this room database class. And from there, we define our entities, the version number of our database. We have helper methods. One is called get in-memory database, and that helps create an in-memory database. You could also create a file-based database if you'd like. So let's take a closer look at, I guess we can't here. So what we have up top is this database annotation, okay? And what I'd like to kind of show, and maybe I don't want to mess around with this. So we pass in the entities here. So inside of these brackets, we say, hey, we have a user class, comma, book class, and a loan class. So we're building like a simple library kind of handout. And then our version is 1. And we have this abstract class app database. We extend room database. Here we have our abstract user model, our DAO models. So our user DAO, book DAO, loan DAO. We have an app database method which says get our in-memory database, and we pass it our context that we're in. And here, when you're creating this, this is where you can say, hey, I want to create this on the main UI thread. This is where I want to deal with this. So that would be where you say, hey, I want to override this. And then here we have another method for getting the file database if we wanted to. So here's an in-memory, here's a file database. And then we have our destroy here at the bottom. Okay. So let's take a look at a function that gets us our in-memory database. Then gets us a list of our user entities. Return from our method here, find younger than solution. So the first thing we do is we say, hey, remember that app database we just created, that class? Well, let's go get an in-memory database and pass it our application context. And we're going to store that in this MDB variable. We have a string builder, and we'll get to that in a second. We have a list of users, and we pass in young users. Our database, we ask for the user model, and then on that, we call this method find younger than solution. Find younger than solution. So we're asking for users younger than 35. All right. So if we go back a bit. Here at the bottom, we have the select star from user, where age is less than the parameter we pass in, and this is that find younger than solution. Okay. So we pass that back. We get a list. We iterate through the list, and we build a string off the string builder, and then set this text view to that. There's one problem with this code, though. Like, we're not doing anything. We're doing everything on the main thread, right? We're not saying, hey, to any of this. Hey, do this elsewhere, right? So the problem with this is going to create is it's going to create jank. And there's options to avoid jank, right? So you could use threads. This works very well with RxJava. So anybody familiar with RxJava and comfortable using it? Okay, so these two play together very well. So you can get your maps, you can pull data back that way and observe that. But the reason kind of why I'm here talking to you guys tonight is talk to you about, oh, that's awesome. Some of the new Android architecture stuff here. One of them is the lifecycle activity. The other one is the view model provider. And the last is the observer. So we're going to see how we could use these three classes to pull together everything that we're trying to do here. First, we'll kind of look at some new entities that we stop in our database. We have a book entity, which is just a primary key string ID and a string title. And our DAO for this, we have a couple of methods here. We have our select star from book where the ID is passed in, load user by ID. And then we have this other one here, which is returning a live data stream of a list of books, okay, which is called find books borrowed by name. And it has some SQL here. So there's a select star from book. We do an inner join on loan, an inner join on user. And all we do is pass in the username. That goes filters through this SQL, and we get a live data feed of a list of books. So that's kind of cool. And you can do this too. Like, you don't have to hook it into some static data that I'm passing through. You could hook this in with like REST data, so you can pull data back from that way. And let's take a look here. So here's our Android view model class. So we have this books borrowed by user view model, which extends the Android view model. And here we have our live data for books, which live data of a list of books called books, and our app database. Here in our constructor, we have our initialization. We call create database, which is just going to get that create in-memory database and populate it. And it's calling this populate async, and I'll show you that in a bit. But here in this constructor, it's finding the books borrowed by Mike. So it's finding the books that I borrowed. And it's doing this by taking that database, getting the book model, calling that method with that parameter. So it's pretty neat. All right, now we want to do something with this, right? So how do we do that? Well, we use our lifecycle activity. So here's just a regular activity that we're extending not from app compat activity or, God forbid, activity itself. Always use the compat libraries if you can. So we're extending from the lifecycle activity. And here we have our view model and a text view that we'll use in a bit. And in our activity on create, we have our initialization. We're setting our content view. We're grabbing our text view from that. If you guys are familiar with Java, apologies. Sorry, Kotlin, I apologize for this being in Java. And then we ask for our view model, and we ask it of this, and we get from that the books borrowed by user view model. And then we call subscribe books. And here we just have this books observe. So we're observing on this for a list of books. So we're asking for that live data of list of books to come through. And when that's changed, when we get the books in, at any point, any time that feed changes, we get that list, and we show books in the UI. We pass in the books that come in from that and the text view. Now, I'm not going to go too much into this method, but it just kind of loops through all the books and prints them into a text view. Okay, I am going to get into it. All right, so here's that show books in UI. We ask for a list of books and our text view, string builder, iterate through it, okay, and we set our text to that string when we're done iterating through. And then when we have this on, we have this refresh button, which basically refreshes the database. And we don't do anything else with this. We're just calling the database to refresh itself. Everything else is still tied in. So what I'll show you here is an example of this. And I'm going to need this. Apologies, it's a little hard to work sideways. Okay. All right. So here is our app database. So we saw this before where we get our in-memory database. And again, here you can allow main thread queries. This is how you would do this. And build from that. And our user activity here. I want to show this part here. Okay. Okay. So we have that populate async. We saw that method before. So what we're doing here is we're saying, okay, we have this populate DB async task. We're passing in our app database, and we're calling execute on the task. And if we look at what we're doing down below, that's going to go ahead and call this populate with test data in the background. And first thing we're going to do is delete all the loans, delete all the users, delete all the books. Right? So we're not calling anything here in SQL. Like, that's all been defined. We're not doing anything here. And notice how none of those methods have implementation, right? So we're leaving it up to Room to determine what's happening here. We define 2 users, user 1, user 2. Rick Sanchez is the first user. Mike Traverso is the second. And then we have a Carol Siever here as well that we add in. We have a couple of books. Dune, 1984, War of the Worlds, Brave New World, and Foundation. And we have some dates. And then here we're going to add each of those loans into the loan database and then sleep for a bit to kind of pretend or simulate kind of a delayed data feed. We don't want it to come in all at once, but I want to show you what's going on here. All right. So that's how we get to populate the database. So now, I go ahead and run this. So let's give Gradle a chance. Installing the APK, okay. All right. So you see that the kind of books come in one at a time. Let's go back in here for a second. And here is our, here we are. Here's our activity where we're calling this from. This is the activity we're running. On our onCreate, we're setting up our activity. We're calling this DB activity layout. Just to show you what this is, we've got a simple relative layout. Inside the relative layout, we have a scroll view, a linear layout with a text view, another text view. So the first text view is books borrowed by Mike. It's just a static string. The second text view is the string we're building with that string builder. And the last is a button to just call refresh. And on that refresh, we call that refresh button click method, which just refreshes the database. So here's our onCreate method again. So we've gotten our content, we've gotten our layout, we get our text view that we need. We define our view model, and we call subscribe UI books, which takes the view model, calls get books, and observes this, right? So we're getting that book method, and we're listening for when that data comes through. And when we have data that comes through, let me open this up a bit so we don't have any lambdas. All right, pardon me, because this is going to be a pain to close. Okay. All right, so here we get this, we call observe, and we have a new observer, and we're overriding this onChanged. So every time that observer comes through and says, hey, I have new data. So first time it'll come through one item. Second time it comes through with 2 items. So you're getting the list of the data that comes back. And then we're calling this show books in UI, which is just this silly method that says, hey, let's put all this stuff in a string builder and put it into that text view. So that's what's happening here. So if I call refresh again, here we go. Cleans out the database, and then one at a time it reinserts them. All right. So I think, and it's fun because whenever I give a talk, Google updates Android Studio, it seems. So today they just came out with Android Studio 3.0. So I encourage everybody to download that. I don't know where they're at with this. I know they, I know Yeet was talking about, Yeet from Google and the Android team was talking about these may not be the exact same class names that they put out when it goes to 1.0. So, you know, play around with some of the code labs and stuff like that and kind of get familiar with just the concepts. But I think this is really awesome because you don't have to define the methods to do that. You don't have the boilerplate code. You write the SQL statement, which you have to write anyway, and then you're done with that. You can do all kinds of operations, and it's much easier to kind of maintain, especially with versioning and whatnot. So this is Android Room and data persistence, and I thank you very much. Any questions?
So that's on data.
What's that?
That's not production yet ready.
Right. So good question. So
Is it room metadata?
I don't know. I think the libraries I'm using are alpha, so I think it might still be an alpha, unless it came out today.
I know 3.0 came out today.
Yes. I think I know that they usually do that where Android Studio comes out, but I think that Room is still, with the other application architecture components, are still
Some
alpha.
of them are out now.
Okay.
I don't know if Room is.
Okay.
What I'm asking, or is what I'm saying.
So what I would do is I would check if you're looking to use this in production. The one of the things that you'd be able to do though is when you're writing your interface DAO, you'd have to figure out a way to migrate the data over from your SQLite database. And I believe that there is some walkthroughs with that on the Google Code developers website. So if you're looking for production.
It's in release candidate 1.
Okay.
So it's probably not going to change.
So is that also compatible with any Android version?
Yes, because they're all, well, I won't say all. I think it goes back to Android 11 or 9. You got the site up? Okay. All right, but I think it goes pretty far back. It's part of the support library.
Yeah.
So it's, again, if you're not using the support libraries, it's kind of a great way to get introduced to them with the architecture stuff. Yes?
So my SQL was very weak, so forgive ignorance here, right? So one thing I noticed a lot of these things will do is they'll auto parse your data for you to see that. I know that in some persistence libraries you have to have like things that can convert from one type to another. Like, okay, well I'm going to store a date like you said, right? But I want to get it back out of the long. Is there a way that you can say, hey, look, before, I understand that I made an interface that said, here's a SQL, here's what I want out of it.
Yes.
But I'm going to like install an adapter that can change.
You can, they're called type converters, and you can use
Oh,
those.
yeah, I saw that.
Yeah. So that would be one way to do it.
Okay.
I didn't want to get into that.
I figured it'd be something.
A lot of it, yeah. Any other questions? Yes.
I thought it was interesting that when you said the file database, that's actually the disk, right?
Yes.
I think it's interesting that they gave you access to that instead of like working through the memory and then calling something on to apply those changes on the disk. So would
Well,
it be?
I imagine it's a file in that sandbox that the app lives in, So I wouldn't get too enthusiastic about what you could do with this and try to hack it. But yeah, I mean, I get your point. Like, that is weird. Like, you can create a database file, but I mean, you're doing the same thing with other, like with SQLite, right? So that I think that's kind of where they're going for that. Like, if you've got a small set of data, an in-memory database might be the best option for you. But if you've got a ton of data, maybe it's better to write to disk. So cool. Yeah.
One more question. You said that it works well with RxJava. Does that mean that they give you like RxJava bindings, so like true observable? Or...
So all that, right? You can so I've not done the RxJava with this before, but you can use all those same RxJava components, right? With all of this, with the data that you get back. You don't necessarily have to create the view models with that, right? What you can, so there's, I forget her name, Florina Montanescu. She's a Googler based in, I think, Germany. And she has a really cool talk on the Realm Academy website where she shows like how to use RxJava and Room.
Oh, that's cool.
Yeah. So if you're interested in doing those two things together, definitely check that out. It's I think it's Realm Academy IO or Realm IO, and you could search for Academy on there.
They actually put a lot of awesome talks.
Yeah. They won't have DevFest Florida talks. We got to them too late. But they are getting it. All the talks will get recorded through Slides Live. So if anybody watched the DroidCon stuff, so those same folks are going to be doing our stuff. Yeah. All right. Well, thank you very much. And hopefully we'll see you guys in a few weeks.